The store can be modified via a reducer function. So let's write here a reducer function. We will call it store reducer. So this is simply a function that takes as first input argument the current state of the store. So we are going to define a variable state and we are going to annotate it with the application state type. The second argument of the reducer function is an action, and we are going to annotate it with the action interface of NGRX store. Now, the store reducer function takes the current state, takes an action, and returns again an application state. So it returns a new instance of the application state. So as we can see, we have here a compilation error because currently the store reducer function is not returning anything. So what we can do is we can do an initial implementation of this function simply by returning the existing state. So at this point we are not processing the content of an action. We can then take this function, the reducer function, and we can provide it here to the store. So this is the main input of the store, a reducer function that takes the current state, takes the action, and returns a new state. In this case, we are not modifying the state yet. But let's say that we would like to process the load user threads action. But let's say that we would like now to modify the state of the store to process the action load user threads. So the first thing that we need to do is we need to detect that the action is of a given type. So for that we can use, for example, a switch statement. So let's switch on action.type. So this is a string and we are going to say here, if the type of the action is load user threads action, then we are going to process this action in particular. What we can do now already is to add here a default clause to the switch statement where we are returning the same state as we received as input. Now what we want to do once we detect that this is a load user threads action, we want to take the current state of the store and we want to load into the store the payload of the action, which contains the user threads, the user participants, etc. So in order to do so, let's, instead of putting the code here in line, let's delegate the processing of this action to a method that we are going to define here. We are simply going to define a function called handle load user threads action, and we are going to call it from here. We are going to pass it in both the state and the action. Concerning the signature of the handle load user threads action, the first argument is the state and the second is the action, but this time we are going to use this concrete class here instead of this interface. And we're going to put here in the return type, this is going to return the application state. Notice that we have an error here. This is because we cannot associate this class load user threads action to the action interface, and this is because this property here is mandatory. But if we mark it as optional by adding a question mark to it, then we no longer receive here the compilation error. So the only compilation error we receive now is due to the fact that we are not returning anything from this function. So now let's use TypeScript to help us implement this method. So we can see here that if we call action.payload, we get an instance of all user data. So let's assign it here to a local variable. User data is of type. If we hover over this variable and we hit Ctrl+Shift+P, we can see that the type of the variable is all user data as expected. Every reducer function needs to return a copy of the state. It's very important that the reducer function does not modify the state directly. So what we are going to do now is we are going to create a copy of the state object. We are going to call it new state. And in order to generate this copy, we are going to use a utility method called object.assign. So we are going to take the empty object, we are going to copy into the empty object the whole content of the state variable. And we are going to annotate this new state variable saying that this is of type application state. Now, if we return this new variable as the output of this function, we are going to see that we no longer have a compilation error. But again, we are simply creating a clone of the state. We are not saving into the application state the payload that we have received from the server. So in order to do that, we can use the new state variable that we have cloned. We can go into store data, and in here we need to fill in the participants, the messages, and the threads. The way that we are going to do this is we are going to assign to store data a new object, and we are going to fill in the three properties. So let's fill in the first property, participants. This property needs to be filled in with a map whose keys are numbers and whose values are the participants. And where are these participants coming from? We can see that they are here available in the action, in the payload. So if you do action.payload, we have just received a list of participants, an array of participants from the backend. So we can try to assign this to the participants variable. You will notice that we get an error. This is because participants needs to be a map with a numeric key and the value being a participant. And this is an array. So what we need to do is we need to take this array and we need to convert it into a map, and we need to use the ID property of each participant as the key of that map. In order to do so, we are going to use the underscore keyBy utility function. We are going to pass into keyBy the participants array, and we are going to specify that the key of our map should be the ID property. Now we need to do something similar to the other two properties, one being messages and the last one being threads. We need to use keyBy to produce a map based on the values of the payload that we received from the backend. So in this case, we are going to also keyBy the messages by their ID. And finally, we are going to key the threads also by their ID. And this fixes our compilation error. So now we have here a function that takes as input an application state, creates a clone of it, and assigns to the value of that new state the data that it received from the backend, namely the participants, the messages, and the threads for this particular user. And so this concludes the implementation of our first reducer function. And we covered a lot of ground in this lesson, so please don't worry, because in the next lesson we are going to first see this reducer function in action, and then we're going to do a quick summary of what we just did and reiterate this important concept of reducers. It's coming right up in the following lesson.